On this bonus episode, I talked to my colleague Dr. Scott McArt, an associate professor in the Department of Entomology, about if we can make bees immune to insecticides and many other topics regarding bees and apple bloom. Enjoy. So, on today's episode, I'm joined by my colleague and friend, Dr. Scott McArt, an associate professor in the Department of Entomology. And Scott has written the most comprehensive review on neonics I've ever seen. And Scott's actually currently in Australia on sabbatical. So we're sitting here on East Coast 8 p.m. time chatting right now. So, hey, Scott.
Hello, Monique. It's, what is it, 10 a.m. my time. So thank you for, actually, this is great. I have been doing most of my meetings at like 5 a.m. and 6 a.m. my time. This is wonderful that you're willing to take your time outside of working hours and work with me during working hours. So thank you very much.
Well, I feel like we're approaching bloom here, and I thought it would be really fun to talk to you about your recent work and maybe try to discuss some best practices for bloom. And I'm going to start out with a little bit of a heavy question, but I think it'll be a very intriguing one to our listeners. So, can we make bees immune to insecticides?
All right. So I'll launch right into this one because, yeah, it's a great question. And we've been actively researching this topic, and it's a pretty darn controversial topic, both within the research community and I would say in the public sphere as well, because it's had a lot of sort of interesting issues about sustainability, about whether we should engineer organisms, et cetera. All right, so just to give you some background on this, I was approached by a materials scientist at Cornell, maybe 5, 6 years ago, something like that. And he became very intrigued by seeing if we could use these microencapsulated particles, feed them to bees. And in these encapsulated particles would be these sort of special enzymes that would detoxify insecticides for the bees while they were consuming them. I remember being approached by him with this question and thinking, oh my God, this guy lives in science fiction world, not in science fact world, right? This sounds really intriguing, like the way he explained it. And he actually came in with some diagrams to show me. And I was sort of, okay, maybe this is science fiction, but it seems like interesting enough science fiction that maybe we should at least try it and just see what we can do. Fast forward about 2 years later, and he had a PhD student and a postdoc who teamed up to do a phenomenal study. And they really showed through a series of very cool experiments that got right up to actually producing these enzymes and then feeding them to bees and doing these long-term survival assays that we could, in fact, make bumblebees immune to organophosphate insecticides. So we could dose bumblebees with way more than an LD50, more than, they would ever be exposed to really in the field with a few different, pretty common organophosphate insecticides. And the bees, it just bounced right off of them or bounced right through them, I guess would be more appropriate to say. They became completely detoxified. So the paper was published in a pretty high impact journal. It got quite a bit of attention, both within the material science world and also within the bee. So anyways, yeah, it was a very interesting study. A company was not produced it turns out, if we fast forward to 3 years, there was some thought about trying to turn this technology into a new company, but a company ended up not being produced. That said, the topic has been sticky, and we are now currently working on trying to make bees immune to neonicotinoid insecticides. So there's a PhD student who just finished trying to use a different approach to have that happen. And the results I can share look very promising. We can certainly have some impact on making bees immune to neonicotinoid insecticides. It's not quite the level of immunity that they had to organophosphates, probably because the approach was a little bit different. So that's good for us to learn. Maybe we should go back to the original approach or try some other different approach.
Yeah, I think we'll probably need to do more field research to see what it looks like outside the lab, right? And how bees are being exposed in the field. I think, maybe we should continue our earlier discussion, which I think is intriguing because there are these two camps, right? People who think you should do conservation in the working landscapes and people who think that you should not. I fall in camp number 2, and I think this discussion is super interesting because there's a lot of information out there. And I think that it would be interesting to talk about how that might work in Apple here in New York.
Yeah. So I think this is a fantastic topic that, again, it touches on the sustainability question. Like, okay, as the camp that we're going to try to improve sustainability by incorporating something into the working environment, like the working farms, et cetera. Or do you have separate areas where you do sustainability, not entirely inside a working farm? And really, the science on this is twofold. Like it can support both opinions. One is, yeah, if you have designated reserves that are outside of apple orchards, for example, those can be really good if they're either managed in a way that's very conducive to pollinators and other, wildlife, or they're just set aside and they're not managed in any particular way. There aren't encroachments of human activities that influence the habitat for things like wild bees. Alternatively, and there's good science that supports that can have benefits for wild bees and other types of wildlife. Alternatively, within the working environment, so let's say, for example, on an apple orchard, if you invest, and I would say that's an important point, right? So this takes money. Any investment takes money to either actively promote pollinators or other types of wildlife, perhaps putting in a wildflower strip would be one way to do things, or just letting the land not be used on the apple orchard and let it go feral, let weeds grow, et cetera. Both of those are ways that you can increase the number of pollinators and habitat for other organisms. And there are certainly ways that, or there's scientific evidence that shows that that can have benefits, even if there's some spray drift that's coming over, insecticides, et cetera. If there's more food for bees and more habitat for them in those areas, there still can be benefits. So it's tricky, right? So like, what do you recommend? It might be a little bit of both, depending on what this particular situation is for a particular person.
I think that if we had more of a potential for organic apples, I think this would be really useful, not just for the pollinator community, but also for the natural enemy community, having alternative resources. But I just feel that the exposure to the insecticides within the apple block is just so extreme and ever-changing landscape too. I mean, we are getting a lot softer chemistries and the harder chemistries are getting banned, but I just don't think we know enough to be able to make a solid recommendation for those exposure levels of all of these different organisms.
Yeah, and I can't speak to exposure for all the other organisms. I just do research on bees, primarily just do research on bees. I'm sure some people who are listening to this podcast maybe even have worked with me before, and folks in my lab. We have done quite a few studies in the past just looking at what exposure looks like in New York to bees, both managed and to wild bees. And I can share, this is in publications, and some of it is stuff that I've shared in unpublished work. But yeah, absolutely, exposure is there. On average, just to throw some numbers out there, honeybees are exposed to 17 pesticides simultaneously when they conduct apple pollination. Wild bees, it turns out, appear to be exposed to fewer pesticides, and in general are not exposed to quite the levels of some of the particularly toxic insecticides. And we can get into why that might be, in a bit. But still, they're exposed to, on average, about 7 pesticides, on average. It's not like bees are just going in there and not being exposed to pesticides, even during bloom, when not a lot of stuff is being applied. There's certainly residuals that are still there, et cetera. And then the other thing that is unpublished, but I want to share for this audience, is the pesticide levels in soils on apple farms is extremely high. There's probably 2 reasons for that. Number one, there's just a lot that's sprayed, over the year on a particular apple orchard. And then the second reason is because it's in soils, the half-life of pesticides in soils is way, way longer compared to on a leaf, in grass, et cetera. Those pesticides are definitely there. Why is that relevant to pollinators? Well, the vast majority of wild bees that conduct apple pollination, and we know that about 50% of pollination in New York apple orchards is conducted by wild bees on average. The vast majority of those bees are ground nesting bees. So if the insecticide levels especially are particularly troubling within apple orchards, it's probably having an impact on those bees. Now, that said, to tie this back into our original discussion where we were talking about not just what's going on in the particularly managed environment of apple orchards, but potentially what's around them, our research has shown, and I think most people who work on apple orchards probably have just sort of see this themselves, a lot of the bees come from forests surrounding the apple orchards. I had a previous PhD student, Cass Urban-Mead, who did a phenomenal PhD showing that all those wild bees that do the apple pollination, most of them, sorry, not all, most of them are spilling over from surrounding forest habitat. So they build up on those tree resources, the maples, the oaks, the various things that are blooming just prior to apple. They build up on those and really utilize those resources in the forest. And they're actually probably living in the forest as well, although we can't really say for sure. Probably building up and living in there. And then they spill over into apple orchards for pollination. So maybe it doesn't really matter. If you have a lot of forest surrounding your orchard, maybe you're going to get sufficient pollination from the pollinators that are spilling over, and we don't need to worry about what's in the soils, underneath the apple trees. Alternatively, if you don't have a lot of forests surrounding your apple orchard, maybe you do need to think a little bit more about what you're putting into the soils and how that might be impacting some of the ground nesting bees.
So I think that maybe this audience is familiar. I'm pretty sure they're familiar with this, but the idea that most of the conservation efforts are aimed towards the wild bees, because managed bees like honeybees, they're going to survive just because there's an industry to support them and propagate them. But I think mechanistically, how do you think the wild bees are becoming less exposed? Is it because their foraging behavior is so different and they are more going to things outside of the apple orchard?
Yeah, so good prompt. And then, so just before I answer the stuff on wild bees, just in case there are any beekeepers, listening, or apple growers who are also beekeepers themselves, it's certainly not that honeybees aren't having problems during pollination. I would say the vast majority of beekeepers who I work with, and I work with quite a few beekeepers in New York who conduct apple pollination, the majority of those beekeepers do say that their bees don't look particularly fantastic after apple bloom. Now, it's not necessarily that, the bees are coming out of apple bloom and they're all dying, right? So thankfully that's not occurring. But certainly there is some stress that is very likely linked to pesticides, given some of our data that we have primary or that we've published before, and some other work that is not going on in our lab. So it's not that, honeybees are necessarily just getting away scot-free, but at the same time, yes, you're absolutely right that beekeepers can manage those bees. And as long as the exposure, during apple pollination isn't necessarily extreme, hopefully they can bounce back. And if, let's say, they receive a 10% reduction in productivity for the year, well, that's a lot better than receiving a 50% reduction in productivity or colonies actually dying. Okay, with that topic now off the table, let's get to wild bees. So where are the wild bees being exposed versus honeybees? So we just published a paper in Journal of Applied Ecology. Let me describe for everyone what the results were. What we found is that wild bees, and I shared this already, but just again to remind people, wild bees were exposed to about 7 pesticides on average. Honeybees were exposed to more pesticides and more potentially toxic pesticides, particularly the pesticide thiamethoxam. It's a neonicotinoid insecticide. What we found when we look at sort of a toxicity weighted risk metric, so, sure, you can say a bee was exposed to 7 pesticides, but how bad really is that? You have to take into account how toxic each of these pesticides are. So we can summarize this in terms of what's called a hazard quotient. And basically, it's just sort of taking into account the toxicity of each of these pesticides in addition to how much what they were exposed to. We found that the situation was actually pretty good for wild bees. So the proportion of the LD50, or the lethal dose for 50% of the organisms for wild bees, was pretty low. We're talking, 3 to 5% of an LD50, not something that's really going to necessarily kill wild bees. It could have sublethal impacts that would not be necessarily good, and that could cascade through generations and potentially be bad. So it's not like there's no risk, which is true for all pesticides, right? There's going to be risk for almost all pesticides. The question is just how much risk is there? That's what we're really trying to minimize. So the situation was relatively low. And also, when we looked at the pesticides that were on apple flowers in each of these locations, they overlapped very well with what was in the bees themselves. So likely, these wild bees are being exposed to pesticides within the orchards, and it's not necessarily really bad levels of exposure. Now we can contrast that with what was occurring for honeybees. Honeybees were exposed to very different pesticides than were on the apple flowers. There was some overlap, but there was also a lot of pesticides that were not in the apple flowers that the honeybees were being exposed to. The worst one was thiamethoxam, and multiple of the honeybees that were coming back to the colonies had levels of thiamethoxam in them that were above an LD50. above the lethal dose for 50% of those organisms. That is very troubling, and it actually triggers what's called a level of concern. So there's a trigger value of 40% of an LD50, where the U.S. Environmental Protection Agency now steps in and says, all right, this is a level of concern. We actually have to consider this when approving this particular pesticide for use in some particular application context. Unfortunately, 56% of the orchards that we did this sampling at had levels of thiamethoxam that were above the level of concern. But if you remember, I told you that it didn't overlap with what was in the apple flowers themselves at these orchards. Therefore, very likely these honeybees were being exposed not within the orchard, but outside of the orchard. This makes sense for two reasons. Number one, honeybees forage over a much larger radius than any other bee species. On average, honeybees in New York forage over about 1.5 kilometer radius. So they'll go out and forage on average at 1.5 kilometers. Some of them will go up to 10 kilometers to forage. Wild bees, especially the ones that are pollinating apple orchards, they're much smaller, and their foraging radius is thought to be about 100 to 200 meters. So way less, like 10 times less than honeybees, or even more than 10 times less. So we think that the honeybees are being exposed outside of the orchards. We also think because of that particular active ingredient, thiamethoxam, which is used quite frequently on seed dressings for corn, that are planted at the same time as bloom in New York, and the dust gets kicked up, right? Anyone who's driven around New York during apple bloom, you probably oftentimes see that dust gets kicked up from when people are planting corn in the fields. Well, we know that a lot of that dust has thiamethoxam in it. So we think that what's going on is the honeybees are foraging outside of apple orchards, at least a proportion of them are, probably on wildflowers that are surrounding those cornfields. Or shrubs or whatever else that the dust is getting onto, and that's where the thiamethoxam exposures are coming from. So I would say, what's the take-home message? The take-home message is actually like the exposure to wild bees doesn't look all that bad. Sure, 7 pesticides on average. It would be great to have 0 pesticides, and no risk whatsoever. But if you look at risk is pretty low for the wild bees that are in apple orchards. I give 2 thumbs up to at least the 20 growers that were involved in this particular study for keeping risk to bees low in their orchards. Where I think the situation changes is, those honeybees, which are probably picking up, or I would say not probably, we hypothesize that they are picking up the thiamethoxam exposures, the neonic exposures outside of the field. That's one of the reasons why I think it's probably a good thing that we now have neonicotinoids on field crops, seed dressing, starting to be phased out in New York. I think that was a good evidence-based decision, which this study also backs up.
I've always wondered in New York, how many, what would your estimate, or maybe the exact numbers, but how many hives are being shipped in from somewhere else in the US versus are New York beekeepers doing most of the pollination?
It varies from year to year. So we actually do have numbers on this. Ag and Markets, New York State Department of Agriculture and Markets keeps some information on this. And then also we keep some information just through personal connections with growers and beekeepers, but also as part of the New York State Beekeeper Tech Team, which is this wonderful state funded program that's unique to New York. There's no other state in the United States that has a tech team like this, but it's a collaboration between the state beekeepers and then also us at Cornell who run this program. And we don't need to get into details of tech team unless you want to, but the knowledge gained from the tech team is really good. And answer your question, it's a mix between beekeepers who are already in New York and some beekeepers who come from outside of New York who actually do some of this pollination. And it varies from year to year. To put a number on it, across all years, on average, it's probably around 75% of the commercial crop pollination comes from New York beekeepers, and 25% comes from at least honeybee colonies that are coming from outside of the state. The beekeeper themselves might actually consider them a New York beekeeper at least part of the time. Migratory beekeeping is a big thing. So a lot of beekeepers, or the bigger beekeepers in New York, do a lot of migration down to North Carolina, South Carolina, Florida, et cetera. and they have residences both in New York and those other places.
That's actually great to hear. I love that our New York beekeepers are doing the most of this because I do think that helps at least limit one of the factors, making such long treks like they do for almond blossom in California. I kind of mentioned this at the beginning of our conversation, but it's getting more complicated to manage insects generally under climate, which is creating probably an increased temptation to put treatments in that before bloom window to try to manage pests that we usually thought of as more like post bloom issues. Do you see anything sort of the future of management with any sort of softer insecticides, or is that just sort of like an illusion when it comes to protecting bees? Is there anything coming that could help us deal with this?
Yeah. So it's a big question, and I think it's a timely question that probably a lot of people are thinking about in New York apple orchards right now or in the last, couple of weeks. And it's also a bigger topic that I would say a lot of people are interested in, not just in apple, but just in crops in general. And I would say, yeah, I have multiple things I would like to say on this, but I'll start by saying that there are softer insecticides for bees that are in the pipeline and that have already been recently released. So, for example, sulfoxaflor is one of them. That is certainly less toxic to bees than neonicotinoid insecticides like imidacloprid, thiamethoxam, clothianidin. It still is not risk-free, right? It's not just like, hey, we've eliminated all risk to bees, but it certainly has a much better toxicity profile than those other very toxic neonicotinoid insecticides. Another one that people are using already is flupyratifurone. Flupyratifurone, to talk in the active ingredient speak, is another one that is much better for bees, much better toxicity profile compared to especially the neonicotinoid insecticides, and is oftentimes considered this sort of neonic replacement. So there are others that are in the pipeline, and there are also insect growth regulators, IGRs, that are either currently being used. One of those is Esteem. So I know a lot of folks, when I was working heavily in apple bloom up until about 3 years ago, a lot of folks were using Esteem, and that is relatively non-toxic to bees. Again, it is still risky, right? There still are effects on bees. It's not like, hey, you've eliminated risk. There's still risk, but it's certainly much or less harsh than some of the neonics and organophosphates, especially. Lorsban was one of the big, ones that where people were using as pre-bloom sprays. I can tell you now from multiple years of longitudinal data, taking data on apple bloom year in and year out, eliminating Lorsban has not only been good for human health, but I can also say that we've greatly improved the situation for bees during bloom. Lorsban is pretty sticky. It sticks around in pollen and nectar from those pre-bloom sprays. And now that no growers are using it, we see that it's not there at really risky levels anymore, which is fantastic. So yeah, I guess the first way to answer that question is yeah, there are things on the horizon and that people are already doing, which is reducing risk to bees from these pre-bloom sprays or even during bloom sprays. There's certainly more opportunity to work in this direction. And that's what I would say is my second thing that I want to say is I would love to continue working on this topic. I think that this is one of the big things where scientists could come in and researchers like us could come in and try to get some solutions for dealing with these pest problems while balancing pollinator protection. I think there's a lot more knowledge that can be gained in a relatively short amount of time on some of these new products and some of the ways of using these new products in more beef safe ways that are still effective against the target pest.
Yeah, I think it's really super complicated. And I think that, the banning of Lorsban has created a bunch of other pest issues that is causing more frequent sprays, at least on my side of the world of looking at things in entomology. So I think it's become that unending question of you eliminate one product that's toxic like Lorsban, but that took care of like, let's say 3 to 5 pests. So now you've got individual sprays going on for those same pests of different AIs. So I think that's the research question right there too. It's not that we're going to necessarily be able to bring back Lorsban, but just trying to be strategic. How do these exposures work? And what is actually the best answer? Is one exposure of Lorsban pre-bloom worse than multiple exposures of a bunch of products that are softer and more narrow spectrum? It's just something that's hard to make a call on, and I think that we don't have a lot of data on. And I think that this topic also suffers a lot from people sort of taking sides rather than
Yeah.
trying to be objective. Like, we're not going to bring a product back like Lorsban, but I do think that it's time to consider, what happens to the IPM program. Do these more frequent sprays also create additional issues? There's no answer to it right now, and that leaves us in a gray area.
Yeah, no, absolutely. I think, we can talk about best practices based off of data, or we can talk about best practices, off of feelings. And I think, having worked in this neonicotinoid world for several years, I can tell you that, yeah, there's a lot of feelings out there, and some decisions are not necessarily based off of evidence. It's based off of people's very strong opinion. This is the role that researchers can play to hopefully improve the information that we're making these decisions off of, if we can actually provide that data. What would be best is if we had, guidance of not what we think is important, but guidance from producers themselves, from beekeepers themselves, about what they would actually like to see, what specific pieces of data would be really, really interesting. So, for example, your topic about or using Lorsban as an example, which is an excellent example. Okay, so we got rid of Lorsban, and that probably improved, again, most importantly, human health, but also probably pollinator health as well. But if it's been replaced now with 5 active ingredients, number one, okay, yeah, that takes time, more time to apply 5 different things compared to, one thing. But what really is the risk to bees, and how effective are those 5 things? And are there other types of treatments that could be applied that would pose less risk to bees? Is there a 6th active ingredient that we're not even thinking of? Or are there timings that those particular applications could occur, which they'll still be effective, but not pose very much risk to bees? Sure, we can try and improve data collection on that topic, but we need to know, not just sort of how toxic particular things are and how effective they are on their own, but the suite of how all of those management practices are occurring simultaneously, and how difficult is it on an on-farm perspective for farmers to really consider those 5 different, insecticides versus, hey, 4 would be really easy to put out, but a 5th would make it really much more difficult. That's the type of information where we need the information from farmers. We need the information from beekeepers for those types of things, as opposed to, just the toxicity information, which us scientists can get fairly easily.
Yeah, I think it's all about refining the understanding on the field level so that we can do research that supports actually answering the question in the field. I think that's a really good stopping point for us. And this has been a controversial topic. Obviously, it always is with bees, but I do think that we covered as much ground as we could in a very short podcast. So thanks so much for joining me on this, Scott.
Thanks, Monique. And thanks to the listeners for being willing to wade into this controversial topic of bees. I will say that I work with quite a few growers, and no one wants to hurt bees, right? Which is wonderful. I don't want to hurt bees. No grower wants to hurt bees. The question is, how do we do that? And how do we still have a productive apple industry and, people making the profits on their particular farms that they want to make? So we can do this.
We want to
work
keep
together.
the small businesses in business. I think that's critical to the overall economy, but that's a whole other, again, wading into a different topic. So thanks again, Scott.
Thanks, Monique.